Imagine a universe where the impossible is no longer a barrier, where the ironclad laws of physics are not chains but threads to be woven into a tapestry of cosmic exploration. For centuries, humanity has stared at the stars, our hearts pounding with the longing to reach them, to touch the edges of the unknown. The speed of light, 299,792,458 meters per second, has stood as an unyielding wall, a cosmic speed limit that mocked our dreams of interstellar voyages. To travel to the nearest star system, Proxima Centauri, a beam of light takes over 4 years, while our fastest spacecraft would crawl for over 70,000 years to cover the same distance. Interstellar travel, the stuff of science fiction epics, seemed forever out of reach, locked behind the unrelenting mathematics of Einstein's relativity. But what if that wall could be shattered? What if we could bend the very fabric of the universe to our will, leaping across galaxies in days rather than millennia? Buckle up, because what you're about to hear will set your imagination ablaze, challenge everything you thought you knew about the cosmos, and leave you breathless with the possibilities of what lies ahead. This isn't just a story, it's the dawn of a new era, a seismic shift that could propel humanity to the stars and beyond. Picture a spacecraft, sleek and gleaming, not merely moving through space, but reshaping it. Space itself warps around it, contracting in front like a cosmic accordion, pulling distant stars closer with each passing second. Behind the ship, space expands, stretching the universe's fabric like a canvas, pushing the point of origin farther away. Inside this bubble of manipulated space-time, the ship sits still, untouched by the impossible speeds that would tear ordinary matter apart. This is no fantasy. It's the culmination of relentless human ingenuity, daring theories, and a global race to unlock the secrets of faster-than-light travel. Stars that once lay thousands of years beyond our grasp could now be reachable in mere days. Entire galaxies, once distant mirages shimmering in the cosmic void, could become as familiar as a journey across continents. This breakthrough isn't just about exploration. It's about survival, about rewriting humanity's destiny, and about claiming our place among the stars. The stakes are nothing short of astronomical, and the implications will echo through the ages, redefining what it means to be human. Why does this matter so profoundly? The speed of light has long been the universe's ultimate gatekeeper. According to Einstein's special theory of relativity, nothing with mass can reach or surpass this velocity without demanding infinite energy, an impossibility woven into the fabric of space-time itself. To put it in perspective, light from the sun takes about 8 minutes to travel 150 million kilometers to Earth. Yet even at this blazing speed, the journey to Proxima Centauri, our closest stellar neighbor, spans over 4 light-years. For our fastest spacecraft, like the Parker Solar Probe, that trip would take tens of thousands of years, a timescale that mocks our ambitions. Interstellar travel has always been a dream tantalizingly close yet impossibly far, a vision confined to the pages of novels and the screens of blockbuster films. But the dream is bigger than curiosity or adventure. It's about securing humanity's future. Earth, our pale blue dot, is a fragile oasis in a hostile cosmos. Climate shifts, resource depletion, or cataclysmic events like asteroid impacts could one day render our home uninhabitable. The other planets in our solar system, Mars with its thin atmosphere, Venus with its crushing heat, or the icy moons of Jupiter and Saturn, offer no easy refuge. Terraforming them would take centuries, if it's even possible. To survive, we must look beyond, to Earth-like exoplanets like Proxima Centauri b or the seven worlds of the TRAPPIST-1 system, 40 light-years away. where habitable zones tease the possibility of new homes. These worlds are close on a cosmic scale, but without a way to cross those distances, they remain cruelly out of reach until now. The dream of breaking the light barrier isn't new, but for decades, it was dismissed as pure fantasy. Einstein's equations were clear. As an object approaches light speed, its mass increases exponentially, demanding ever more energy until the requirement becomes infinite. This relativistic wall seemed insurmountable, a fundamental limit etched into the universe's code. Even our most advanced propulsion systems, ion thrusters, nuclear rockets, or solar sails, achieve only a fraction of a percent of light speed. The math was brutal, the physics unforgiving. Interstellar travel seemed doomed to remain a story, not a science. But then, a spark of rebellion ignited. Visionary scientists began to question the rigidity of those laws, daring to imagine that the universe might hold loopholes, hidden pathways through the fabric of reality. What if, instead of pushing a ship to impossible speeds, we could make space itself do the work? What if we could fold, stretch, or compress the universe to bring our destinations closer? This radical idea, born from the fringes of theoretical physics, set the stage for a revolution that would change everything. The breakthrough came from a stunning realization. To travel faster than light, you don't need to move faster than light. Instead, you manipulate space-time itself. Imagine a spacecraft encased in a bubble of distorted reality. In front of the ship, space contracts, pulling the destination nearer. Behind it, space expands, pushing the starting point farther away. Inside this bubble, the ship remains still, carried along by the warping of the universe like a leaf on a rushing river. This concept, known as a warp drive, doesn't violate relativity because the ship never exceeds light speed within its local frame. It's space-time that's doing the heavy lifting, bending the rules of physics to make the impossible possible. The idea first took shape in the 1990s, when a bold theorist proposed a model grounded in general relativity. The concept was simple yet mind-bending. Create a bubble of space-time that compresses space ahead and expands it behind. The catch? It required exotic matter, material with negative energy density, a substance so strange it challenges our understanding of physics. Exotic matter could stabilize the warp bubble, but producing it in meaningful quantities seemed like a pipe dream. Critics dismiss the idea as a mathematical curiosity, a thought experiment with no practical application. Yet the seed was planted, and the race to turn fantasy into reality began. Today, that race is accelerating at a pace that defies belief. Research teams across the globe are building on that original vision, refining it with breakthroughs that make warp travel feel tantalizingly close. One group, working in a cutting-edge lab, proposed a modified warp drive that sidesteps the need for exotic matter entirely. By cleverly manipulating the geometry of space-time using known forms of energy, they've slashed the energy requirements from the equivalent of a planet's worth of fuel to something potentially achievable with future technologies. The math is rigorous, the simulation stable, and the concept no longer feels like a dream. It's a blueprint. Another breakthrough came from an unexpected source, the quantum world. Researchers studying the Casimir effect, where quantum fluctuations create tiny negative energy fields between closely spaced plates, discovered naturally occurring warp-like structures at the nanoscale. These nano-warp bubbles, mere fractions of a millimeter in size, are fleeting but real. Their discovery sent shockwaves through the scientific community, proving that space-time distortions aren't just theoretical, they can exist. If these effects can be scaled up, they could form the basis for macroscopic warp drives, turning a laboratory curiosity into a cosmic game-changer. Meanwhile, Other scientists are looking to the stars for inspiration. Using advanced computer simulations, they're analyzing gravitational waves, ripples in space-time caused by cataclysmic events like black hole mergers. Their hypothesis is audacious. What if these waves carry signatures of naturally occurring warp bubbles created by advanced civilizations or even rare cosmic phenomena? By studying data from observatories like LIGO, they're developing methods to detect these signatures and reverse engineer them. If they're right, we could leapfrog centuries of research by mimicking the technology of a superior species, proving we're not alone in the universe. This isn't just science, it's a detective story written in the language of the cosmos, with clues hidden in the vibrations of space-time itself. The implications of faster-than-light travel are almost too vast to comprehend. Imagine a journey to Proxima Centauri taking hours, not millennia. Colonies on distant exoplanets could become as routine as settlements on new continents were centuries ago. The TRAPPIST-1 system, with its 7 potentially habitable worlds, could host human outposts, each a new chapter in our story. Interstellar trade could flourish, with resources like rare isotopes or knowledge from alien worlds fueling a galactic economy. Communication across stars could become instantaneous, uniting humanity in ways we can't yet fathom. But it's not just about travel. Warp technology could unlock new forms of energy, perhaps tapping into the quantum vacuum or harnessing the power of collapsing stars. It could rewrite physics, revealing secrets about the nature of space-time that make today's technology seem primitive. We could become a Type 2 civilization, harnessing the energy of entire stars, building megastructures that dwarf our current ambitions. The ability to bend space-time might even open doors to time manipulation, letting us glimpse the past or shape the future in ways we can barely imagine. Yet the path to this future is fraught with challenges. Even the most advanced warp models require energy on a scale that dwarfs our current capabilities. While reduced from impossible to merely astronomical, the power demands still push the limits of what fusion or antimatter could provide. Stability is another hurdle. Warp bubbles could collapse, releasing bursts of radiation that endanger crews or nearby systems. Then, there's the specter of causality paradoxes. If a ship arrives before it departs, it could create scenarios where cause and effect unravel, leading to consequences we can't predict. Imagine a message sent to the past altering history, or a ship's actions in the future reshaping its own origin. These are not just puzzles, they're existential risks that demand solutions. Ethical questions loom large as well. Who controls this technology? A single nation, a corporation, or a global alliance? Unequal access could deepen divisions, while militarization risks turning the stars into a battlefield. The discovery of alien life, if it comes, could upend our philosophies, religions, and societies, forcing us to confront what it means to be human in a universe teeming with others. Despite these challenges, the emotional weight of this moment is overwhelming. For millennia, humanity has gazed at the night sky, from ancient stargazers charting constellations to modern astronomers peering through telescopes. Every culture has felt the pull of the cosmos, the yearning to explore, to discover, to belong to something greater. Faster-than-light travel is the fulfillment of that ancient dream, the moment we step beyond our cradle and become citizens of the universe. Imagine your descendants telling stories of a time when the stars were out of reach, their voices filled with awe at how we dared to break the light barrier. This is the legacy we're building, a testament to our courage, our ingenuity, and our refusal to accept limits. It's a legacy that will echo not just on Earth, but across the galaxies, carried by ships that surf the waves of space-time. The race to perfect warp technology is happening now, in labs and simulations around the world. Scientists and engineers, driven by the same passion that sent humans to the moon, are working tirelessly. Private companies sensing the potential for industries that could reshape economies are pouring resources into the effort. Space agencies are collaborating, sharing data in a spirit of unity that recalls the Apollo era. Somewhere, in a high-security lab or a flickering computer screen, the first warp drive is taking shape. It might be a clunky prototype, far from the sleek starships of fiction, but it will be the spark that ignites a new age. In 10, 20, or 50 years, you might stand on the surface of a distant world, breathing air under an alien sky. You might watch as humanity's first interstellar colonists take their place among the stars, or communicate with civilizations we can't yet imagine. This isn't just a scientific breakthrough, it's a human one, a monument to our unrelenting drive to push beyond what's possible. What does this mean for you? It means you're alive at the cusp of history, witnessing the birth of a technology that could change everything. You might not board a starship tomorrow, but you could see the first tests, the first glimmers of a warp bubble in a lab. You might live to see humanity take its first steps into the cosmic unknown, planting our flag on worlds we once thought unreachable. The universe is vast, but it's no longer beyond our grasp. We're on the verge of a new chapter, one where we're not just dreamers, but explorers, builders, and pioneers. The discoveries of recent years have turned a once impossible vision into a tangible goal. Warp drives are no longer confined to the pages of novels. They're the subject of serious research, backed by real data and real results. The future is coming, faster than light itself, and you're here to see it unfold. So stay curious, stay inspired, and keep your eyes on the stars, because we're about to make the impossible real.